We're now ready to define one of the most basic algebraic structures called the group. A group is a set together with an operation that follows certain properties. You've already been working with groups. You've been working with the integers under the operation of addition. You've been working with real numbers using the operation of multiplication, and many other sets and operations that you've seen so far, including the integers modulo n with addition mod n, are all examples of groups. Essentially, you start with a set and an operation, and that operation is going to allow you to combine elements of that set to make another element in the set. Not all sets and operations, of course, have these properties, but the properties that we're interested in will be part of the definition of a group. And in defining a group, we need to define something called a binary operation first. And then, once we're done defining groups, we're going to look at several examples of groups. And one of the examples that we're going to look at involves something called dihedral groups. These are groups of symmetries. And these arise in art and architecture and even in science. Crystallography and crystal physics use 3D groups of symmetry. So, for example, this is an example of a crystal structure, and it has symmetric properties that follow certain guidelines. Physicists have used these groups to predict the existence of elementary particles that were later found actually by experiment. One of the things that you're going to be working on is the symmetric group of rotations and symmetries of a square, and then you'll be able to generalize that to a cube. I'm going to start with the symmetric group of rotations and reflections of an equilateral triangle. And from there, we will take off into many more complicated groups and ideas involving them.